the TLDW. We used components from a dead GTX 960 and some trace repair work to bring back to life a Fermi-based GT 730 or 430. I don't know, I can't see a difference between them except the sticker from the PCB. Like pretty much all my adventures in board repair land, it all started with an ad for a GT 730 that had, as the seller mentioned, a few missing components. I'll skip the fact that despite showing up as a GT 730, it's more a GT 430 in both GPU and memory. I have another video regarding that, see link in the description. And we will focus instead on the work that was needed to be done to get the board running. I already mentioned that some components were missing, and the silk screen printed for the back of the PCB area did manage to provide a bit more information that was not possible to convey from the ad, despite the seller's upscaled picture of the same area. Zooming in too much showed the pads to be still in good condition, but it also got the markings outside of the frame. According to the notations, I had at least a missing decoupling capacitor. Not a critical issue, 3 others of similar value were still present, and a missing inductor, LB502. That was definitely a critical issue. Those kind of inductors are usually placed on various power, or less frequently, enable lines. An open circuit on those lines will render the board useless. Unnoticed from the ad, however, the board also had some problems with the PCIe lanes. 3 missing capacitors on lane 6 and 11. Judging by the missing pads and the broken traces, they seem to have been ripped off from the board. Now, the seller did mention that he got the board from a car flea market, so I can see this kind of thing happening, when boards get treated pretty much like a wooden plank. Before doing any soldering work, I did the usual resistance measurements. 12 volts PCIe to ground, 3.3 volts to ground, between various chokes and ground, and fortunately I got values in the "this is fine" range. I proceeded with lifting an inductor bead from a confirmed dead GTX 960 and a similar capacitor to fix the back of the GPU area. Having some flux helps not just to get the good solder connection, but also to keep the components from moving away on their own. While the flux is still liquid, you can shift the components easier in place. You then heat the area gently so that the flux thickens and gets really sticky, and the components will stop flying away. After placing the inductor and decoupling capacitor, I wanted to check if it's still worth continuing with the repair of the PCIe lanes. There would be no way to confirm the fix if the GPU itself is dead. Since the affected traces were on lane 6 and 11, the card would still boot and display an image when slotted in by simply working in PCIe x4 mode. The card did show an image after this initial fix, so I now had a good enough reason to proceed with the repair of the PCIe lanes. I first scraped off the solder mask from the affected traces. Lane 6 had 1 missing capacitor, so only 1 trace needed fixing. It also made sense to try first fixing lane 6. A success here would enable the card to work in PCIe x8 mode. Fixing lane 11 before fixing lane 6 would have no effect without using lane reversal, and the card would still list as PCIe x4. After scraping the solder mask, I used the good old soldering iron, get it, to thin the trace. I then used a piece of copper wire to rework the trace and left a bit of extra wire to act as a pad. I then lifted a similar PCIe lane capacitor from the donor GTX 960 and used a drop of liquid flux to float it and then secure it in place. Heated up the area and done. Lane 11 was a bit more difficult. I had 2 traces to repair and then float 2 capacitors. The process was similar. Scrape the solder mask, tin the traces, use flux to float and secure pieces of tinned copper wire, then use the hot air to solder them on the traces. Just like lane 6, I left a bit of extra wire to act as a pad, and then slightly bent the soldered pieces of wire outwards. A bad solder joint would typically pop off when performing this maneuver, so besides allowing me to form some crude solder pads, it also helped me detect such bad joints and redo them until they were properly done. Again, lift one more capacitor from the 960, float it, place it, heat it until soldered. Rinse, repeat for the second capacitor of lane 11, and I was ready. Before slotting in the card, I used the multimeter in continuity mode to check that the capacitors were connected properly to the traces leading to the PCIe fingers, and to also verify that the neighboring PCIe fingers were not shorted one to another. I then switched to diode mode and placed one probe on each capacitor terminal placed towards the GPU and the other one on the ground plane. I got proper forward voltages on the undamaged lanes and on the repaired lanes. Still in diode mode, I then tested the forward voltage between neighboring capacitors on the ends towards the GPU. Again, I got similar values between undamaged lanes and the repaired ones. After a quick sanity check involving resistance measurements on the powering lanes, I reassembled the card and slotted it in my workstation. The card worked. I got the correct drivers installed. The GT431s, the 730s won't detect the Fermi GPU properly, and fired up GPU-Z. Skipping the fact that Nvidia and Asus had the audacity to call GT730 what is actually a Fermi-based GT430, I could notice that the PCIe information was PCIe 2.0 x 16 at PCIe 1.1 x 16. While I was glad to see the times 16s after the @ sign, I didn't like the 1.1 version listed there. But a few seconds later, after doing a stress test in the application, GPZ updated that field, and it now listed the card working at full PCIe x 16 version 2.0. The final touches consisted in a thin coat of clear nail polish covering both repaired traces and capacitors, followed by a bit of blue nail polish on the repaired traces alone. Heaven ran fine, at least for the class of GPU of the GF-108. The card is still in my PC at the moment of writing the script and shows no signs of trouble. Being the second card to be rescued by using parts from a donor board. And use the drop of liquid flux to float it and then secure it in place. The final touches consisted in a thin clear of